So this week is all about this picture that I showed you in the last lecture, and how this applies to our Memorize game is that we're going to use this to build the game logic so that it actually plays the game, hopefully by the end of Wednesday. Let's just zoom right back into our code. This is where we left off last time. And let me review a little bit where we are here so far versus that other picture. What you're seeing here, this class, you see where it says class right there, emoji game, that is our view model. So in this picture back here, that's this little thing right here, right? That's the green thing. And over here, this is our model. In our picture over here, it's this blue thing down here, right? That's our model. And we've already built our view, or it's currently called content view. We're going to change it to be something else, but we've already built that piece of it. Notice also as I click here that I called that file Memorize Game. I ended up calling the struct Memory Game. So let's just rename that, and you're allowed to go in here and just rename things like this, Memory Game. If you wanted to rename the actual struct, then it's a little more things involved, right? Because you're naming the struct and the file and other things. And I'm actually going to show you how to do that when we rename content view to be something like emoji memory game view, some better name for it than just the content view. So I'll show you that in a second. Now, if we go back here to our view model, you'll notice that where we left off is that we created a var for our model. Our view model back in this picture over here, it has full connectivity down to the model. It can talk to the model, anything it needs, because its whole job in a way is to understand the model and talk to it and interpret its data and present that to the view in a really nice way. Sometimes I like to call the view model the view's butler. Okay, have you ever watched Downton Abbey or one of these things? You see these old-time butlers. They set the table so you have a nice meal, and they arrange all the things. Well, that's what the view model is doing, taking whatever's in the model and arranging it nicely so the view has this beautiful, simple code. Everything's really understood, well understood. That's the role of the view model. So, of course, the view model has this var right here. And we're going to go over into our content view. I'll just throw it in there right now. And we're going to put a var in our view. I'll call it view model, that's a bad name, but it's going to be of type emoji memory game. In other words, we're going to have a var in our view that points back to our view model. Of course, because it's our butler, we need to be able to ask Jeeves for the things we need. We have to be able to ask it, so we're going to have a var pointing to it. By the way, I think I said this before, and I'm going to say this 5 more times. I called that view model. You would never call the var in your view model. You would call it game or memory game or something like that, something that's meaningful. I'm calling this var view model, and I'm calling this var model, just so that you are clear that's what these things are, but that's not what you would call them in real life. It's just for understanding what's going on here. One thing, if you look at this picture back here, the way that's set up with those two vars, a var here that points here and a var here that points here, notice there's no var here that points here. There's no vars, and there never will be any vars in my view model that point to views over here. The only way the view model talks to the view is with that something changed. The view model just say, oh, something changed in me. And then it's the view's responsibility to pull the things that are interesting to it. That's because it's a reactive, stateless thing that knows how to pull its data and see if things have changed, and if so, redraw only the things that need to change. That's all part of the view mechanism. So you'll never have a var in there. Also, of course, you would never have a var here that points up here. This is UI independent. This is part of the UI. So that's just completely verboten to have something here knowing about this. That would make absolutely no sense, right? UI independent, these two things are part of the UI. So that's the relationship between all of these things. Actually, let me say one more thing about the relationships between these things too, because in the slides, I talked about like a partial separation and a full separation, and then like putting your model in an at-signed state, which is like almost no separation, remember that? So what you're seeing right here is partial separation. And why is that? That's because over here in my view, I have this var, which points to an instance of one of these, and this var is there. And so there's nothing that stops me in my view from saying view model dot talk directly to my model. But I can prevent that if I want. If I want full separation, I can put this word in private. If I make that private, that means that the only code that can use this var, see it or talk to it, is this code. It's private to this class. Now, if I do that, how is the view going to get the cards and do the things it wants? Well, in that case, it's the view model's responsibility to, for example, provide a cards thing that returns an array of memory game of string dot cards, right? And this is just going to return the model's cards. And this might seem totally ridiculous to have this just one liner that is returning that thing right there, but it actually is protecting model from the view. The view has to go through the view model to get at things. And it really probably is a little ridiculous in our case because our model is so simple. It only has two things, the cards and the choose function. That's the entire model. So maybe it is, maybe that's why I said maybe this partial separation would have been good enough. We could have left our model public. But if we do make it private, then we not only have to do that to make the card so the view can see it, but we're also going to have the func choose a card, which chooses a memory game of string dot card. And this is going to have model choose that card. It's going to have to provide everything. This, by the way, this function we would call an intent function. Remember I talked about intent, view models have intent. This is the user's intent to choose a card. And we're going to see more about intent functions. We're actually going to do a different intent function before we do this one. So this would be full separation right here. Private model, only the view model can see it. It makes public whatever function vars it wants to do it. Now, let's also talk a little bit about protection in the model side, because this var cards, clearly other code needs to see those cards. If I can't see the cards, I don't know which ones are face up, I don't know which ones are matched, whatever. However, I wouldn't want someone to reach in here and change my cards, like start flipping them up and down. You know, the game has rules about when the cards can be flipped up and down and when they match. And that's all going to be done inside this choose method. I don't want some other code reaching in here. So there's another protection I can put on here, which is almost the same, called private set. And private set, it's just like private, but it means only setting this variable is private. Looking at the variable is allowed, so people can look at it. And this is what this model would do for sure, because we do not want someone interfering with our game logic by flipping cards over externally, right? So that's only something we can do. So it's private to us, but we want people to see our cards. This thing of putting private and private set on things is called access control. And there's some other access control that have to do with public libraries and all that, but just private and private set is really all we're going to deal with in this class. And it's 99% of the access you're going to do unless you're a framework writer or something like that. And I'm going to suggest to you, when you write your code in the real world and here, that you start out private. Unless you know you want this to be public, you start out private. Now, sometimes you know right away you want it to not be private, like here. View model definitely wants these to be public because it wants the view to be able to call them. So there's no question, this can't be private. But any other vars or things you have, kind of lean on the side of private and then make the decision, okay, I'm going to let other code call this. But realize that once you do that, you're kind of locked into leaving it that way, because the person writing the other code might not be you. It might be someone else in your team or someone in another team in your company. And once they start calling that function, you got to leave it there. You can't take it away from them. That's the way I kind of think about doing the private stuff. All right, so that's access control. You know, by the way, while we're here, you see this function choose card. This is of type card. In your reading assignment at the end, there's a little document that talks about how you choose the names of parameters to functions. And it would say very clearly, this wants to be internal only and have no external name. In other words, no argument on caller side. So how do you do that? Well, it's actually incredibly easy. You just go here and you put underbar. This is the external name, internal name, but the external name is underbar, which means no external name. So when people call it, they're just going to say choose, and they're not going to provide the argument. They're not going to say choose card colon the thing. And why do we do that? This is completely redundant to this type. This is a card. It's clear it's a card. You don't need to say it's a card. It is a card. When do we have these names? There's numerous reasons to have it, and that document will tell you. But I'll tell you the top two reasons. One is this is a string or an int or something where it's not clear what it is. It's not a specific type like a card. It's a string. Well, what is that string? Another one here is if some external name would make the code read a lot better. This is like the example we saw, move. So move takes an offset to how much to move. And if you just said move provided the offset, then are you moving the offset or what? But if you say move by offset, you put by colon in there, it just reads better, right? I'm moving by the offset. So those are the two primary reasons you're going to put the names in there. Or like we saw with image, where image can take different arguments, like image system name means go look at the system images. Image named colon means go look at my named images, right? That means different things. But again, that's kind of, you're passing a string. You got to describe a little bit what that string is. We would do the same thing, obviously, over here in our memory game. This one, we would also say choose underbar card. And back here, we would not have this. Pretty cool with that? All right, that was just a little aside right there. I happened to be right there. Okay, we have had this error sticking in our face the whole time I've been talking to you. Class emoji memory game has no initializers. What does that mean? Why is it saying that? I told you that classes get a free initializer. We already know structs get these nice free initializers, like our card view had that free initializer. It had the content and the is face up, remember? And then we gave is face up a default value. Now we didn't have to say is face up, but we could. That was all really cool feature. And we never had an init initializer for our card view. Well, classes get the same thing, but their initializers have no arguments. So they only work if all of your variables have default values. And we have a variable right here, model, that has no value. And so that's why I'm saying I can't give you the free initializer here because you have some uninitialized variables, so you have no initializers. Please give me one, it's saying. So I could give it an init, and we're going to see an init in a second here in our model, but instead I'm going to try to give this a value. Equals, how about memory game of string with no arguments, possibly? Can I do that? No, because there's a missing argument, cards. Okay, memory game of string is a struct. Its free initializer lets me initialize all of the variables. And if I go back here and look at my model, it's got an uninitialized variable, which is the cards, the array of cards. So it's saying, oh, that's a struct, fine, no problem, I'll let you do this, but you've got to provide those cards. In other words, it wants me to say something like cards are something, but that makes absolutely no sense here. We've got a memory game model. It knows how to play the game of memorize. It knows how to create the, it's the one who has to create the cards into internal array and all this stuff. Besides, it wouldn't work because this right here is private set. Only we can set those cards anyway in our code. So it just makes no sense to have cards be the argument. And that's where initializers come in. Because what does make sense if I'm creating my model? Well, I claim that what makes sense is that I should create it with the number of pairs of cards, like maybe 4 pairs of cards. This is not a var in my model, but it's the information my model needs to create itself. And when we have that kind of situation, we go over to our model here, and we are going to have to create an init. So this is a function. You don't say func, you just say init. And it can have any arguments you want, like number of pairs of cards, which is an int. And you can have multiple inits, all with different arguments. Perfectly fine, okay? And anyone who's trying to create you can call any one of your inits to get it created. And your job inside of an init is to initialize all your vars. Now, some of them might be defaulted, so you don't have to do anything here. But like in our case, we've got that cards. We have to initialize it. So I'm going to start by making this card to be an empty array, which is just array of card, open parentheses, close parentheses. Array is a struct. Get the free init. Array doesn't need anything, any arguments, so boom, that creates it. And yes, we could use that alternate array notation here. I could say card, open parentheses, close parentheses, perfectly legal. And believe it or not, can also do this. And this kind of freaks people out at first, but it makes perfect sense actually, because we know that this notation is how we create a literal array. We did it in our UI over here when we had our emojis, see, open square bracket, and we listed a bunch of strings in that case. Well, here I'm just doing open square bracket and not putting anything in there. That means empty array. And in terms of the type, Swift does type inference. It knows that this card right here is of type array of cards. So it knows that's an empty array of cards. Exactly what I want. And that's exactly how we would do this, by the way. Now what I need to do is to add number of pairs of cards times 2 cards to that array. Everyone agree that's what I need to do? I'm trying to initialize myself. I got to go put my cards in there. So, oh, by the way, let me take a time. I decided my writing was so slow and hard to read. Instead, I'm just going to put these up here, and then I'm just going to put a little thing around them when I'm talking about them. So access control is what we talked about. Right now we're talking about init. We're in the middle of doing an init. And now we're on the next one, which is a for loop. Because we need a for loop. We're going to go through that many number of cards and do it. So what does a for loop look like in Swift? It looks like this. For, I'm going to call it pair index in a range, 0 dot dot number of pairs of cards. Do something. This is the only way you can do a for loop in Swift. I'll show you what this looks like in C so that you can compare it, but it would be something like for pair index equals 0, pair index is less than the number of pairs of cards, pair index plus plus probably. This is what it would look like in C. And actually, this thing makes it seem like in Swift up till version 3, you could do this. We're on Swift 6 now almost, so can't do it anymore, but that's the equivalent there. But I really don't want you to think of it this way as the equivalent for this. Instead, I want you to think about the fact of what's going on here, which is that this is your iteration variable, of course. This is anything that can be iterated over. So not just a range like this, but it could be an array or any collection that can be iterated over in order. So we use for in a lot, obviously, to iterate through things. The syntax really is for control variable in iteratable thing. So here we're going to go and do that many pairs of cards. And what are we going to do? Well, we're just going to add cards. So I'm going to say cards.append. Append is the function in array that adds something to the array. And I want to append a card. So I'm going to, here's my card down here. Remember our card struct down here. So I'm going to say card. And I'm going to use, actually, I'm going to use the free initializer. You see it right there? Boop, free initializer I get because I'm a struct. The card struct is a struct. And my cards are going to start out face down and unmatched. And oops, we got some card content here. We'll have to talk about how we're going to do that. And of course, I need 2 of these cards, right? This is a matching game where we are trying to match cards. So we need 2 of each card that is matchable. Everybody cool with what I did there? Now, what is that warning here saying? Immutable value pair index, the iteration variable there, was never used. It says consider replacing it with underbar. In other words, it's saying consider doing this. Take this and go underbar. And that's exactly what we would want to do here because we don't use pair index in here. So we still want to iterate this many times, but we don't care what the pair index is. We don't use it in this code. So we would use underbar. You're probably starting to get the message. Underbar is the Swift thing for just don't put anything here, right? Like underbar we did here and choose card. That means don't have any argument there. And the underbar here means I don't care what the iteration variable is because I'm not going to look at it. This code is interesting because you see is face up and is match false. When I create a card, they're always going to start face down. And they're always not going to be matched. We have to start playing the game until the cards get flipped up. So this is an obvious case where this wants to be defaulted. Equals false down here, equals false. And then we could just take this stuff out of here. We don't really need that. And this is the exact same thing we did in our card view, right? It's an obvious thing to do. While we're down here looking at card, I also would never put colon bool here because Swift can infer that from the fact that the value is false. False and true can only be that. And I'll do another interesting thing here too. This content, I'm going to make that a let because if I have a memory game card where the contents are changing as the game's going on, that's going to be a very hard game to play, right? So let's just assume for now that our cards, the content stays the same on a card. So that wants to be a let, not a var. It's not going to change. But face up and his match do want to be vars, because as you tap on the cards, they're changing their face up. And sometime, hopefully, they get match and their match would change. So those would need to be vars. So this is what I was talking about, that kind of explicit mutability here. We want to mark the things that can be changed. All right, what about these? This is the card content. You could imagine having a let content of type card content equal what? Maybe card content, open parentheses, close parentheses. Actually, no, we can't do that. Card content is a don't care for us. We have no idea in this code what card content is. We don't even know if it's a class or a struct. We know nothing about it. So there is no way that we can call an init on it. We don't even know if it has an init, because we've already learned, for example, that structs, they're free init even, will have any vars that don't have values in them. So there's no such thing as init with no thing here for a lot of structs. And we know the classes only get this free little thing here if they have no vars that are not set. So we don't know that. We know nothing. So there is no way for us to create this content. We are just incapable of doing it. We do not have enough information in this code to do it, because it's a don't care for us. We just don't care what it is. So what do we do now? How are we going to create our cards? Well, who does know what this card content type is? The code, or the person, if anthropomorphize it is, who creates us, right? If we go back and look where this is being created, it's right here, memory game of string. This guy knows that card content is a string. In fact, he knows it's an emoji, not just a string. He knows it's an emoji. He knows everything about what this don't care for that guy is. So this guy has to be the one to create the content. But this guy is still the guy who knows that he has to create that many pairs of cards, and he knows how to set up the cards. And so we got a little bit of a problem here. Well, we got one piece of code needs to kind of get some information out of another piece of code. How are we going to do this? Well, this turns out to be super easy to do. All I'm going to do is add another argument to my init, which I'm going to call my card content factory. And its type is going to be, anyone want to guess? What? An array of card content. That would be a way to do this, right? You could pass in an array of card content and you could use it in there. And that's, I'm really glad you brought that up, because that's how you probably would do it in all the languages you've done. But this is functional programming. So we are going to actually have the type be a function that returns card content. So this is a variable or argument that's going to be passed to our init, which creates a card content for us. And then down here, instead of trying to create it this way, I will just say, call the card content factory, please, with no arguments in this case. And I could probably even be a little better than this. I'm going to bring back my pair index right there and pass it along, so that the card content factory can do that, use that if it wants. So I'm just going to go back here, pair index. I'm going to pass that pair index here, which makes this now become a function that takes an int and returns a card content. And it's that fluid and that simple to have these things, passing around their various values. This is really the heart of why we call this functional programming, because we allow the different parts of the code who own the knowledge of how to do things to pass their knowledge along via passing a function. We're going to be passing functions all over the place in this class. And so here's your first example. And this is not even like we're doing this sophisticated thing. This is a basic, this is a simple little demo, and we're still using functions as types here. So get used to this. It's new to a lot of you, I know, but you'll eventually get used to it. Now, of course, we want to use this content that we created as the content for both of the cards. So we'll put that on both of the cards right here. And we can also do a lot of Swift type inference here. We don't need that. Swift can infer that type because it knows that this thing returns a card content. So we don't need to explicitly type what it is. And the same thing back here. See, we have this model, which is of type memory game of string. Don't need that because it knows that that's what we're creating here. And here's the incredible thing. We don't even need this. As long as our card content factory here returns something that's a string, then this is going to be a memory game of string. You can even infer from the return type of the function I passed what it is. This function, how do we pass this on our end? Well, a lot of you are guessing, ooh, this is going to be an inline function. Ooh, and it is. But first I'm going to create a global function that does this. I'm going to call this create card content for pair at index, which is an int, it returns a string. And I just go back here and grab my emojis that I happen to have right here, copy them, put it over here and say return that thing at that index. Everyone cool with this function? Does that look like what we want? We're just going to grab the emoji at that index. And does everyone agree that this is a function that takes an int as an argument and returns a string, which is what this argument is supposed to be? All right, then I can just say right here, card content factory is create card content. And it's completely legal to do this because this is a function that takes an int and returns a string, and that's what the type of this argument is, so I can pass it in there. Now, we would not do it this way. We would, of course, use a closure. How do we get from the closure syntax we've been seeing in our other code, how do we get to there from this function right here? Well, let's just take this function and select the whole thing except for not its name because it's inlined, so we don't care what its name it is. And I'm just going to copy this here, and then I'm going to paste it in place of this card content here. And before I do that, though, so you can see it clearly, I'm going to put this on its own line. I'm just going to paste in what I copied. Ready? Paste. And now every time I do that, I have to change two things. I got to take this open curly brace, that's this one up here, and move it to the front so that the curly brace contains the entire closure. And then I replace it with the word in. Let's do that. Take this out of here, cut it, replace it with in, and move this over here. And that is a completely valid closure right there, except for this. Let's say here, closures cannot have keyword arguments. I happen to call my function, have an external name and an internal name for pair at index. That's not allowed with a closure. So I have to take this out of here. Now we have a completely valid closure. Look, no errors. It's fine. I promised you that I wouldn't have to say memory game of string because it would infer it from this return type, which it did, which is kind of cool. But this still doesn't quite look like the closures we've seen before. It looks similar, though, to this one. Remember this one? For each index in, it looks awfully similar to that. And in fact, this is just a closure that takes one argument, which is the iteration variable of your for each. So that's what's going on there. But it looks a little simpler here. It just says index in, whereas over in our one here, it has all this parentheses, index, int, arrow, string. Well, why is there all this extra cruft here? Why don't we have it over there? It's because over there, we're using type inference. Clearly, this thing knows that this whole expression here is a card content factory, that it's a function that takes an int and returns a string. So we don't need to say explicitly that it returns a string. It knows that. Can infer that. Same thing here. It knows that the index is an int. We don't need that. And very nicely, just to kind of remove excess parentheses, if you just have that going there, you can just get rid of the parentheses. Also, we know that this memory game creation thing has two arguments, the number of pairs of cards and the factory. And when the last argument is to a function or a creation, what can we do with it? We can throw it on the outside, trailing closure syntax. So let's get rid of this whole thing, close off our function there, and leave that on the outside. And since we're doing that, we can also do this. Maybe clean this up a little too. Looks like that. So that's pretty clean. Just threw that, all the stuff that was up in here, we just threw it right in line here with kind of minimal syntax around it. And so we don't need this thing anymore. Just get rid of that. A couple more minor things we can do here. One is this index here. If I were to replace this with $0 and say this $0, well, $0 is a special name. Okay, $0 means the first argument, and I could have $1, $2, however many I want. And if I use that special name, then I don't need to say $0 in. So $0 is a placeholder for the first argument if you pass it. Now, we could do that here. I would recommend against it here. I don't think this is that readable. In fact, not only would I bring back index, I would call this pair index in and call this pair index. Just to make it clearer to someone reading my code, what's actually going on there. Now it reads as the model is a memory game with this many cards, and we create the cards by using this pair index to index into this array. It kind of all makes more sense. People can understand what's going on. So $0, you'll see me use it later, and you'll start to get the feel like, oh yeah, I see why we would do $0 there and we don't use it here. The other thing I think kind of messy is that we've got this embedded array like right in the middle of our function. That doesn't really look good. I think I want to take that out, call it something like emojis, say let emojis equal that. Don't we agree that that just kind of looks nicer? This is a nicer looking code. But we got a problem here, and this is a big problem. And this is an important problem to understand what's going on here. It says, cannot use instance member emojis within a property initializer. Property initializers run before self is available. It'd be intimidating to read this, but it actually makes a lot of sense. So what is a property initializer? That's when you have a property. Remember, I told you we called vars and lets properties in Swift. So this is a property called model, it's a var, and I'm initializing it here. And the reason I'm initializing is because if I don't, I'm going to have to do an init. So I want it to essentially have a value to start. So I'm initializing it. I'm giving it an initial value. This let emojis, this is also a property initializer because it happens to be a let, but it's still a property and I'm giving it a value. The important thing to understand in Swift is that the order that your properties are initialized is undetermined. It's not in the order you show them in the source code. Okay, the compiler compiles them all up and they can be in any random order. So you can't use one to initialize the other because we don't know when we initialize this whether this has even been set yet because maybe we're doing this one first. So that's why we can't use emojis there. Well, that's a bummer because it would be really nice to be able to do this. So how do we fix this problem? What we're going to do, I'm going to start by saying I can fix this problem by having emojis be a global variable. Right? So I made emojis just be a global variable, global to my entire program. When I put let emojis up there, that's global. I could use that anywhere. My views, my model, it's completely global. Now, everyone in this class knows we don't use global variables. They're bad. They completely pollute the namespace. They provide access to things that you maybe don't want other people to see it in your code. It's terrible. We don't use globals. But it did solve the problem. Look, I don't have that anymore because I'm not trying to use one of my other vars to initialize var. So how can I get the best of both worlds here? Well, the answer is I'm going to put this back in, but I'm going to add the word static to the front of it. And what this means is make emojis global, but namespace it inside of my class. The real name of this var is now called emoji memory game dot emojis. That's its name. This is a nice global variable name. It is not going to pollute the namespace. Nobody else is going to name a variable like that outside of my class. And what's really cool, private. Now it's a private global variable only for us to use, but it solves this problem very, very nicely. And another cool feature is not really type inference, but Swift, if you're doing a property initializer like this and you use one of these namespace globals, you don't have to put the extra thing in there. It'll figure out, oh, emojis? Oh yeah, you probably mean this global right here. I'll use that. So that's cool. Question? Exactly. The question is, by making that global, am I making sure that it's initialized before I use it here? And that's exactly what I'm doing, because the global variables will be initialized first before my things. Yeah. That's static vars. We can do the same thing with functions. What if I wanted to make a nice little function to create my model? So I'm going to create a func called create memory game, and it's going to return this. So I just made a function do this, and then I'll call the function here, create memory game. Oh, we got problems here. A lot of problems. Let's look at this problem first. Cannot use instance member create memory game within a property initializer. So this is a different problem. We're going to solve it by using globals, but it's a different problem. I'm trying to use a function, a func, in my class before I've even initialized my class, right? What am I doing here? But model equals this. I'm trying to initialize my model variable. I'm trying to initialize my class. It's not initialized yet, so of course I can't call a function on myself yet. So that's what this is saying here. Cannot use an instance member, that function instance member, within a property initializer. And that's kind of obvious, right? I have to initialize myself first before I can start calling my own functions. How do we fix that? We can also make that static, a static func, a global function. It's inside, so it's called emoji memory game.create memory game. In other words, the name of this function right here is emoji memory game.create memory game. What else we got here? This static func return memory game, of course, it has a return value. It returns a memory game of string. So that fixes this error right here where it's saying unexpected non-void return value, because I originally had no return value, so it was void, and yet I was returning something there. Also notice here that emojis, which is a static var, can be used inside a static func without the long name. Yeah. Great question. Why can't we infer return types here? Return types always have to be explicit. That's the one thing you cannot be inferred in Swift. Can never infer a return type. And when we say some view for the var body, it's not inferring the view. It's actually looking in there and seeing what it returns and setting it to be that. Model here, obviously, since it's using a global now, it does not need this because of this magic where Swift knows that if you call create memory game and it's a global func that's namespaced inside here, we don't need to put that in there. And yes, of course, we would make this be private because we never want anyone creating a memory game for us. So this is our own internal thing we're using to create our memory game. I like to put, as a style thing, my statics at the top. They're global to my entire thing. I really want them to be listed first, or sometimes we'll put them at the very bottom, either the bottom or the top, but put them together. I think having statics scattered out through, I'm not a fan of that. Some people might say that's good. You put them near the code that wants to use them. I buy that argument too, but I like to kind of group them. Anyway, these two clearly go together, and this is a nice creation of our var. Yeah. Yeah, and if you guys have done your reading, you'll know that these statics are actually called type variables or type functions because they're really a function on the type itself, on the emoji memory game type itself. I don't describe them that way in class because people get confused by that. Well, a type function, I don't get it. It makes more sense to people as a global variable that's just namespaced in here, but they are in fact type variables or type functions. That's a good clarification there. Now, we have seen these kind of global variables namespaced in other places, like over here. We didn't even notice it was happening in our view. How about this guy? This is actually color.orange. This is the type color, it's a struct, and .orange is just a non-private static var. So let's go take a look in the documentation here. This is, I did option click on something. That's how you can see the documentation for it. I'm going to open the documentation itself. Here's color. You can see there's a lot of ways to create colors here, various inits, creating it different ways, HSB or RGB. If you look down the bottom here, look, static let brown, static let clear. These are just static let vars. They're public, so I can use them. And let's look at some other ones. How about down here? Font. This is font dot large title. Let's go look at font. Open it up. Scroll down. Look at this. Right there, large title, etc. These are just static vars. So when you see these dot whatever things, they're one of two things. They're either static lets on types, or they might be enums, because enums also have this kind of dot notation. We'll see. I'm going to talk about enums in slides right at the start of Wednesday's lecture. So that's it for static vars and lets. The reason they're confusing to people is just because they look so much like a normal let or var, but they have that word static, which of course completely changes them to being these global namespace things or type variables, or if you want to call them that. But they look so similar, people get a little confused. So we're actually done with our view model, and we're done with our model except for it doesn't know how to choose yet. So the next step is to use this in a view. But before we do that, I'm going to show you just some Swift code being written, because I've hardly written any actual Swift code, like if-thens and stuff like that. We just haven't needed much of it. I'm going to do one here. What I'm going to do is I'm going to protect this line of code so that this array index is never out of bounds. So I don't ever want this thing to call me back to create a card with an invalid pair index. Now, I'm sure my model would never be so rude as to do that, but I still want to protect myself. So I'm just going to put a real simplest thing here. I'm going to say, if my emojis indices, remember what that is? That's that range, right? We use that in the for each. Contains, so range has a function called contains, where you put something in there. This pair index, then I'll go ahead and return the emojis at that index. Otherwise, I'm just going to return some kind of like oops emoji. Let's go find an oops emoji here. Emojis and symbols. This one. And that's my oops emoji. So if I start seeing that in my UI, I got a problem with my model or my view model or something. So I'm protecting it. I'm also going to protect my model over here. Because what if you say the number of pairs of cards is 0? That's not going to make much of a memory game. In fact, even 1 is not a good memory game, because you got to have at least 2 cards. So I'm going to say max 2 number of the pairs of cards. So that means it's the number of pairs of cards, but it's at least 2. Max is just a little Swift function, takes a couple arguments. It's generic, so the arguments could be floats or ints or whatever, right? It allows you to do that. There's a don't care as to what those are, as long as they're comparable. That's what they have to be. It does that. Now it's time to use our view model. If we go back over to here, we're going to use this green thing, which is pretty much done, and the model, which is done except for choose. We're going to use this in here to drive our stateless UI. So let's see what it looks like to drive that stateless UI with the model that we have right here. And this view model only has 2 things, cards and choose. Everything else is private. So the only thing the view is going to use is these 2 things, but that's really all our view needs, is be able to see the cards so it can present them, and when you tap on a card, it needs to be able to choose. So that's all our view needs. It's also packaged up very nicely for our view. Let's go over here. Before I do this, I'm going to rename this from content view to be emoji memory game view, because again, content view was just the default we got when we created a new project. Didn't know what we were doing, so it just picked content view as the content of our UI. And the way to do this is you command click on it, and you'll get a bunch of options here, which is kind of fun. You can add some documentation, which will put a little comment in there. You can add methods and properties, and you can also rename things. And this is semantic rename. This is a rename where it's kind of looking throughout your entire project and renaming. So let's click that. Here it is. Now it's searching through my app to find every place where I'm actually using this semantically. And it even found some places where it's just mentioned, but it's not 100% sure, like it's in a comment. You see that second one up there? And that one, it's not blue, so it's not going to actually replace that. But if I click on it, plus, now it'll replace it. So the ones that it semantically knows, that's content view, it'll queue it up to be replaced. Other ones you might have to add. This is my main program. Of course, content view is at the top level of him, so it's in my Memorize app right there. And then this is my content view, that's my comment, and the file name too. I'm going to just change it right in line. Emoji memory game view. That's what this thing is. It is a view onto an emoji memory game view model. That's what it is showing, yeah. Command click. Command click. I selected content view and I said command click, and that got that menu. And feel free to explore that command click menu. It's got a lot of cool features in there. All right, so now I can hit rename up here in the upper right, and it renames it. You can see it renamed my file over there. It renamed my actual struct, but it did not rename, way down here, my previews. You see this preview here? Content view previews. It didn't kind of figure out that that's what's going on. I'm not sure why it doesn't do. I'm especially not sure why it doesn't rename this one, because this is semantically that content view. Anyway, you got to do this manually. Emoji, memory, game, view. And I could use copy and paste, I guess, here. Copy, paste. And there is rename over here, too, in the navigator. There's a replace. But that one, you're just doing textual find and replace. It's not, there's no semantic knowledge there in that case. So we still have one important error here, which is that this var is never set. And so down here in our previews where we're trying to create one, it's saying missing argument for that parameter. So we have to say view model something here. I'm going to postpone doing that by sort of cheating and just say equals emoji memory game. And this is bad. Don't ever do what I just did. This is just because I want to postpone doing the right thing until I can explain some other stuff to you. You never would set your view model this way. I'm going to show you how to set the view model soon, but you would never do it that way. I know you probably hate it when I say that, but some things have to be done in certain orders, unfortunately. So now we're going to do this using view model in a view. And really, this is quite simple. We're just going to get rid of all the stupid assigned state we had for the demo and use our view model to get all the data that drives our view. I'm going to start right down here in my card view. I'm just going to get rid of that. And I'm going to replace it by having card view have only one argument, which is a card. Right? It's a card view. It's supposed to show a card. So we should give it a card. I'm going to go here and say var card, which is a memory game of strings card. And I'm actually even going to make it a let because I can't default it to anything. And once it's set, I'm not going to be updating it inside of this card view. Now you might say, what about is face up? You're going to be updating it here. No, because this tap gesture thing, it's not even going to be in here. It's going to use the intent in the view model. So it's not going to be changing it locally here. So we can, in fact, just get rid of this entirely. We'll put it back in when we have got our view model going here. And then we just replace our content. So our content here is now the cards content. Remember that memory game.card, it has the content, which is this don't care, which is a string for us, and is face up. Similarly, card has is face up. This one also. Now changed this card view into truly a card view. It is a view on a card. And if we add things in the future, which we're going to, like is matched, right? We don't use is matched, but when we do the is matched stuff, it's going to be in here because the card view is the thing that draws a card. So that really is nice, not just in making our code simple here, but it kind of semantically, conceptually makes sense that we've got this card view and it draws a card. And then back up here, the other thing, problem we have, make some space here, over here, we've got our emojis. This emojis up here. So emojis now are handled by our view model. So we're not going to have emojis in our view right here. And instead of iterating through our emojis, we're going to iterate through our view model's cards. So we're going to go through each of our view model's cards. The indexes are view model's cards. And of course, we know our card views don't take content anymore. They take cards. So we'll say its card is view model cards at that index. Simple? Understand what we did there? We're just for eaching through the cards now instead of for eaching through that emojis thing. and then we're going to pass each of the cards down to the card view. All right, no errors, no warnings. That's all that's really required. Let's take a look and see if it's working. Preview on pause. Oh, there it is. Nice. Now, of course, can't see our cards, so we're not really sure it's working. But let's flip those cards over and look at them the other way around. Now, how do we do that? We go to our model or to our view model because that's where the truth is now. So we don't even touch our UI if we want to look at these cards face up. We bounce over here, in this case, to our model, and we're going to say that all the cards start face up instead of face down. And when we go back here, get this thing to rebuild, voila, we see all our cards face up. Similarly, the number of cards, that's in our view model. It controls that. So let's go change to 6. Back here, rebuild. Now we have 6 pairs of cards. One thing that was kind of annoying here is every time I went to my model or view model, I lost my preview. I couldn't see my preview anymore. Well, you can pin it. You see that little pin? That will pin this here so that even when I go over here and change something, it stays there. Let's go 10 cards. It'll change it right in line here, and we can see 10 cards. Or even if I make too many cards, like 16, we'll get those little question marks because we have too many more cards than we actually have in our array. And that's all happening. The pinning is what's keeping this here as we change our model to view model. Pretty cool, pretty easy, makes the code really nice. I could make the slightly nicer here in my view, by the way, which is right here. You see this card view cards? That's redundant again. That's like we had with that other thing, the choose, where we put the underbar in there. We got the same thing going on here. This is a card. This view model cards add an index, that's a card. We don't need to say card here. But whoa, how are we going to fix that? Because that's not a function. That's the creation of our card view. That's the automatic init that's getting created for our struct that initializes that uninitialized card. So the only way to get around it, provide an init. If we provide an init, we get to control that external thing. So I'm going to say init, and you can even say tab to make it create it for you. And you'll even put this little line here, self.card equals card. So this is equivalent to the free init. And when I hit init tab, I got the free init. This was the free init. And I'm going to change it just ever so slightly to have no external name, just like I did the other thing. I'm going to go up here, get rid of that. That looks a little nicer. The next thing I actually want to do is add some UI to our app here, which is a shuffle button that shuffles these cards. Because shuffling the cards really will help us understand what's going on in these internal data structures when they're moving and how our UI reacts. But before we do that, I want to make one small change that I didn't get to make at the end of lecture 2 because we were rushed for time, which is I want to change the size of these things to be not so small. You see how they're font large title, but even large title is just too small. I want them to be as big as the card will allow. So how am I going to do that? First thing I'm going to do is see that lazy V grid up here, and I promised you that I was going to explain all this to you and how it works, and I am going to. That's going to be in lecture, what is this, lecture 4? Lecture 6. But I'm just going to do something real quick here, which is I'm going to set the spacing both vertically and horizontally of this thing to be 0. See, all my cards, they have no space in between them. And then I'm going to use padding to provide the space. And the reason I want to do that is, first of all, this is simpler to control. If I wanted more padding or less, one number instead of having to change both those spacing numbers up there. But you also see that it's going to lead into the other thing I'm going to do, which is try to pick the size of this card that fits nicely. And when we do that, we want to have the padding be taken out of the equation. Now I want to do that font thing. I'm just going to go down here to this font large title, get rid of that. And instead, I'm going to use font system font of size. And let's start with a really big font. Okay, so that's good. I can see those emojis are really great. Unfortunately, it's doing two things wrong. One, it's getting cut off because the minimum width of that lazy V grid is keeping these minimized, but the height can be anything. So it's getting cut off. And two, it's controlling the size of the cards. It made the cards bigger. I don't want that. I want the cards to be their normal aspect ratio, which this is not. and I want the thing to fit down. Well, incredibly, there's a fantastic little view modifier called, what do they call that thing? Minimum scale factor, 0.01. And what minimum scale factor says is if this font is too big, you can scale it down all the way down to 1/100th of its size. That's what this 0.01. So that's great. That's working a lot better. It's scaling it down, but it's doing the vertical size. You see? So it did scale it down, but these things, because our aspect ratio is that way, they're still not quite fitting. Easy fix to that. How about dot aspect ratio 1? Content mode fit. By making the aspect ratio of this text be 1:1, it has to fit that inside our 2:3 aspect ratio, and now it fits. So this is now fitting anything. Let's go back up here and make our cards, let's say, really big. 120 fits perfectly. Make them really small. How about 45? They fit down in there. So let's go back to a size that we like. What do we like? 85? Yeah, 85 is pretty good size. Let's go and do what I was saying, which is adding shuffling to this. I'm going to put a little button on the bottom here that shuffles the cards. This is the kind of thing we all know how to do now. Make a V-stack. Has the scroll view of the cards, and then it has a button, which we'll call shuffle. And inside here, it's going to ask its view model to shuffle. So this right here, this view model shuffle, is an intent. Remember I talked about the way the view talks to the view model is it has these intents. And these intents are user intents, what the user intends. And the user intends when it clicks shuffle, please shuffle the cards. Now we don't have that intent in the view model. That's why it's complaining about it. So let's go add it. We go over here, put it down here, and I'm even going to create a little mark dash intent and then say func shuffle. This mark, if you put / mark dash, then up at the top here in your navigation bar, you'll see that intents will get its own little lined off space. You see how it got its own space up there? As you're kind of navigating around, you can make your own little thing. So / mark. If you don't put the dash, you still get the little marker, but there's no line in front of it, right? No line before the intents there. Intents are important. We'll give them their own little lined off space. And how would we shuffle the cards? Well, one way we might say it is, oh, I'm going to take the model's cards and shuffle them. Now, this is not going to work. Why is this not going to work? Because we cannot use a mutating member like shuffle on an immutable value. Cards is immutable. Oh, yeah? Is it? Oh, it is. Look at that. Private set. We can't touch those cards. So how are we going to shuffle the cards? Yeah, we're going to have the model support it. If the model doesn't let you muck with the cards, then if it's going to allow shuffling, it has to do it. So I'm going to have a func shuffle here, and I can shuffle my own cards because I'm inside my model here. And then back over here, we will just say model, please shuffle. So again, this might seem like, what a waste to have these one-liners here, but this is full gatekeeping mode, which we probably don't need for memorized games. So simple, but I want you to see how you do the full gatekeeping. This is how you do it. Here we are in the model, and we said shuffle here, and it's complaining even inside here. Why is this complaining inside here? I'm clearly the model. I can private set, I get to set. Why can't I shuffle my own cards here? And the answer here is that self is immutable. Self meaning the model is immutable. So if the model is immutable, how does it ever change anything? How does it flip over the cards or do anything? Well, it can. It's just that any function that can modify the model has to be marked mutating. Why does Swift force us to put this mutating here? Clearly Swift knew it was mutating. It gave us that warning. So it knew it was doing it. Well, it's saying put that there so that you know that you're doing it. Because someone calling this function is going to cause a copy on write. Remember I told you Swift does copy on write its value, we're passing these arrays of cards, we're passing the whole thing in there, and only when someone touches it, then we actually make a real copy of it. That's how it knows. When it says a mutating function, so it wants you to know that if anyone calls this, Swift is saying, I'm going to do a copy on write for this. So I hope that's what you intend. Everyone understand that? So Swift will not let you mutate your own struct without putting mutating on there. Let's go back to our UI right here and resume. We've got shuffle down here. Boom. Oh. What's going on here? It's not shuffling these cards. What is happening here? Well, actually it is shuffling the cards. It's shuffling them beautifully. And let's go into our model and see that that's what's happening. I'm going to go here where we shuffle. I'm going to print the cards out. Now, when we did print before, I think we said print, quote, toggled. Remember that when we were doing the on tap gesture? Here I'm saying print cards. Okay, cards is an array of cards, and it allows that. So what happens when you print some random struct? Well, Swift is really good at turning it into a string. It's a little bit of a verbose string, and we're going to show you a little bit how to make it less verbose, but we're going to be able to see what's going on. So let's go down here to our console. Remember, just drag up from the bottom. And this is the debugger on the left and the console on the right. So I'm going to close the debugger to give us a lot more room in here. And I'm also going to put it on previews mode. Now, some of you don't have access to Xcode 14.3. So to do what I'm doing here, you're just going to hit the run button and run it on your simulator. And then it will come out here from the simulator. But we can do it in the previewer here. So let's go down here and hit shuffle. Whoa. So it's printing all of my cards out there very verbosely, but it does appear to be shuffled. You see that this is the array. Here's one card from here over to here. Really long name. See, it's telling me all the vars, everything, all the content. And then these are all the cards. And it is in some random order. So it's definitely shuffling the cards. So why is our UI not updating? Well, it's because of this. Reactive UI. This reactive part, you have to do a tiny bit of work to make it work. Okay, just a tiny little couple of protocols you need to use. It's real easy. So let's do that. We start with our view model right here. And we have to make our view model behave like a view model, essentially behave like something that says something changed when things change. We do that by making it implement the protocol observable object. Makes sense, right? It's an observable object. And this observable object protocol has a var in it. I'll put this var so you can see it. It's called object will change. Don't worry about the type right there. This object will change var is the var that you send a function to when you want to say something changed. So right here, when I do shuffle, I could say object will change dot send. And that says this object will change. Notice this object will change, not object did change. So actually, when I said in that other slide, something changed, it's really something is about to change, so get ready. And the system gets ready and then lets the changes happen, and then the view can look at all the changes. And we're not going to talk about why that is, but it actually makes a lot of sense to kind of queue up that there's going to be a bunch of changes and then see what the differences are once all the changes are made. But the great thing is, you're almost never going to call this, and you don't need this var, and you can see that it's not even required. It's not like var body where it's saying where's your object will change. It's provided for you behind the scenes. You don't do that. So how do we get an observable object to say something changed? We mark any var that can cause that as published. If you put @ published on a var, then if this var changes, it'll say something changed. And this is the primary way that we do the something change. We just mark vars. Now this var is private, but that doesn't matter. Okay, private just means that the view can't see it, but that doesn't mean it can't cause something changed. It can. It has nothing to do with published and private. People get confused because publish sounds like you're making something public, but it's not about that. Okay, publish means make something changed happen. And then over here in our view, we have to mark this var right here, our view model, as an @ observed object. Means that it is observed. Okay? Now this only, you can only mark a var that is an observable object to be an observed object. And what observed object there means is if this thing says something changed, redraw me. Now it does that super efficiently. It's only going to redraw the views that actually have changed because of that change, but that's what that means, observed object there. Now, this, when I put that on there, this makes a line of code I never want you to ever write in your entire Swift programming career, which is you have observed object and you're saying it equals something. That is a major no-no. Okay, observed objects always have to be passed into you because they have to be marked as truth, as state. An observed object is not a truth thing. It's just saying, I'm observing this thing. So never say equals there. If you really feel like you had to do that, you can use a different one here called state object. Remember we had @ state? This is @ state object. But this is really not that much better than just doing @ state and your model because it's only inside this view. So you could never share this view model with any other view because this is @ state, an object because it's a class, inside your view. So you wouldn't do that. So how would you do this? Well, you would make this be observed object, and you wouldn't have this be here. And instead, everyone who creates this would pass it into you like any other struct, right? You have a var here that's not initialized when you create it. So for example, in our preview, we create it. So here I would say my view model is, and I'll just create it on the fly here. This is okay to create on the fly because your preview is constantly getting redrawn all the time anyway, so you don't care that it's created on the fly. But the other really important place you would change it is in your app, right here. View model, I'm going to call this game, and this game would be an @ state object in your app. So apps, like views, can have @ state objects, but somewhere there needs to be state. Now, you wouldn't always have your view model be created at the app level because maybe you've got some, like maybe you're doing an app with 20 different games, memorize just one of them. You might have a view that shows thumbnails of those 20 games. Okay, and you click on them and it plays them. Maybe the @ state object is in that view because that is the top level. No one would use it any higher level than that. You see what I'm saying? But somewhere it has to be @ state because it has to be marked as truth. An @ observed object, I'm surprised they even allow it. I think they should not allow it. I think you should not be able to say equals anything at the end of here. I just think that that causes way more problems than it fixes. All right, so now hopefully we have a reactive UI. Let's try it here. And here, shuffle. Woohoo! Look at that. Shuffling. Perfect timing. And what we're going to do next time is, I'm not going to teach you animation, but I'm going to use animation to show you all about protocols and care a little bit and all those kind of things that we saw in the slides, because we'll need all that to make animation of these cards shuffling, because I want these cards to fly all around the screen when we shuffle. And then, of course, after we do the animation here, I'll show you how to do the game logic, which is 10 lines of code to make the entire memorized game logic. We'll do that all on Wednesday. It's going to be tight, but we'll do it.